All right, let me not be just a floating voice for a second. So I'm going to do some problems from the remediation assignment, and then whatever questions you guys have, or if you want more of a certain example or stuff from Delta Math you're working on and can't figure out, just whatever you guys need to feel like you're ready for this test. I do just want to let you know, I don't think it's going to be an issue, but we are recording the meeting. Okay, so just don't do anything inappropriate. All right, so let me switch this back around. Okay, so first part of Unit 7 was operations with functions and then composites. So this is something that you guys messed up a lot on the test the first time. These two are composites. Okay, that's where we put one function inside the other one. These two mean to multiply the two equations by each other. Okay, so make sure you're clear on the notation and what the question is asking. So I'm going to do just a couple problems from this remediation assignment that I sent out. So for that one, let me erase these real quick. All right, so we're assuming that f of x is 3x squared and g of x is 2 minus 5x. All right, and then I'm going to do 51. So 51 says f of x times g of x. Okay, so that would mean 3x squared times 2 minus 5x. Okay, and we are distributing here. So 3x squared times 2 would give me 6x squared. 3x squared times negative 5x would be negative 15x to the third. All right, and you can leave it like that. We're just multiplying the two out. Okay, and I want to show you the difference if I asked you for the composite. So if I asked you for f of g of x, like this, okay, that means to plug the inside one, plug g into f. Okay, so I'm going to take g, I'm going to put it in where x is in f. So now I have 3 parentheses, 2 minus 5x squared. All right, I plugged g into f. And remember, this is the tricky one. If I'm squaring something, I can't just square 2 and square negative 5x. All right, I have to actually FOIL this out. So I have 2 minus 5x times 2 minus 5x. Okay, so we do that. 2 times 2 is 4. 2 times negative 5x is negative 10x. Negative 5x times 2 is negative 10x. And then negative 5x times negative 5x would be positive 25x squared. All right, so I'm going to write that in standard form. So I'm going to write 25x squared minus 20x plus 4. And remember, that is all still multiplied by 3. So we're going to distribute that 3 there. Okay, so now I have 75x squared minus 60x plus 12. Okay, so make sure it's a notation issue, but make sure you understand the difference between this is f of x times g of x, right? And most of the time they'll have parentheses there. This is f of g of x. Okay. All right, using these same two, f of x and g of x, if we wanted, let's say, f of x plus g of x, okay, that means put the two together. So 3x squared plus 2 minus 5x. All right, and we're combining like terms. Well, there are no like terms there, but we can write it in standard form at least. So 3x squared minus 5x plus 2. If we did the same thing but subtraction, so f of x minus g of x. Okay, so now I have 3x squared minus, and if I were you, I'd put this in parentheses, minus 2 minus 5x. Okay, the reason is a lot of you will do minus 2, but you'll forget that it's minus negative 5x. So if I were to write this in standard form, I would have 3x squared minus negative is plus 5x and then minus 2. All right, and then the last kind is division. So if we had f of x divided by g of x, okay, you just put them on top of each other. So 3x squared over 2 minus 5x. Evan, move it up closer. Is that good? All right. Okay, so far so good? Anything you want to ask questions about there? Okay. The other thing that we can do with composites, so like if you're looking at that remediation assignment, this would be number 57, but this is I think the easy part for you guys. So if f of x is x squared and g of x is 3x plus 1, and they want f of g of 2. All right, this was, I think, the easy part for you guys. All right, so you start inside out. So I'm going to plug 2 into g. That's what I'm going to do first. So 3 times 2 plus 1, that'll be 6 plus 1 is 7. I'm going to take that 7 and plug it into f. So 7 is x squared, so 7 squared is 49. All right, so f of g of 2 equals 49. All right, but I think that was the easy part for you guys.
Miss Speaks, what's the test gonna be like? Like, is this gonna be like stuff like this? Like, how are
Yeah,
you gonna? Okay.
yeah. It's there's some multiple choice and some free response, but
Okay.
we have a the Microsoft Forms that we're using have like a math type option so that you guys can type like square roots or fractions or things like that if you need to.
Okay.
Second part of this was inverses. So if you remember seeing this notation, so this is f of x, and then we have f negative 1 of x. That's the inverse. Hopefully that looks familiar to you. All right, so if I wanted the inverse, I'm gonna do 68 and 71 from that review sheet. Okay, so f of x equals the square root of x plus 4. Okay, if I want the inverse, so remember the way to find the inverse is switch x and y and then solve for y. So f of x is the same thing as y. I'm switching x and y. So now I have x equals the square root of y plus 4. And I'm going to try and get y by itself. Okay, I can get rid of this square root by squaring both sides. So x squared equals y plus 4. And then move that 4 over. X squared minus 4 equals y. That is my inverse. All right. Also with the inverses, you will be asked if this is whether or not the inverse is a function. Okay, so for that, you have a couple options. Really, the only place that's not going to be a function is if it's a square root at the end, like not the original problem, but your inverse answer. This would be a function. X squared minus 4 is a parabola-shaped graph. It would look something like this. And remember, if we're checking it's a function, we're looking at the vertical line test. Would a vertical line touch that graph in more than one spot at the same time? No, so it's a function. All right, so that was 68, and then I'm going to do 71. Okay, so again, f of x is y, and I am switching x and y. So I have x equals 3y squared plus 1. And I'm solving for y. So I'm going to subtract 1. X minus 1 equals 3y squared. I'm going to divide by 3. And we're going to leave this like that. And then the last thing I have to do, get rid of the squared part, is take the square root. Anytime you're taking the square root, it has to be plus or minus. So plus or minus the square root of x minus 1 over 3, that is equal to y. Okay, and so this is the inverse. And we would say this one is not a function. If you were to graph this on your calculator, you would see something that looks like this. But the calculator doesn't graph the plus or minus part. So that's the plus part. Well, the minus part looks like this, and then that would fail a vertical line test because it touches the graph in two different places. So anytime you have a square root, it has to be plus or minus, and it's not going to be a function. All right, so that is part 1 of Unit 7. So if you're retaking Unit 7, Part 1, that's everything you need to know. So I'm going to pause there for a second. Is there anything else you would like me to go over? No? Everybody's good? Okay. All right, the next part of Unit 7 is direct, inverse, and joint variation. So are any of you planning on retaking that part, Unit 7, Part 2? Let me know if you are. If not, I'm not going to bother going over it if nobody's going to retake it. But if you are, I will gladly go through all the examples. Okay, so we have a couple people. All right.
Can we leave if we only have to retake
if
part
you're
one?
only
Okay.
part 1, you are free to go.
Okay.
Okay, so variation. We have 3 kinds: direct, inverse, and joint. Okay, direct variation, y equals kx. Inverse variation, y equals k over x, or you can write it as xy equals k. Sometimes you'll see it both ways. All right, and then joint variation, y equals k, x, z. All right, those are the formulas that you need to know. Remember, k is the constant of variation. All right. So there's a remediation assignment for Unit 7, Part 2. So that's what I'm looking at right now. And I'm going to skip down first to the second page, and we're going to look at number 13. So it says x varies directly with y. All right, and x equals 27 when y equals 6. Find x when y equals 2. So when you read these things, you really want to break it up because it's really 2 separate problems. So x varies directly as y. That tells me that my equation is going to be y equals kx. All right. X equals 27, y equals 6. So 6 equals k times 27. I want to solve for k, so I'm going to divide by 27. All right, we're going to leave this as a fraction, but they can both be divided by 3. So that would be 2 over 9. So k is 2 over 9. All right, so that means my direct variation equation is y equals 2 over 9k. Then the second part, find x when y equals 2. Okay, so y equals 2. Sorry, that should be an x. And we're looking for x. So I'm going to divide by 2 over 9, divide by 2 over 9. Trying to do fractions in my head. This would be 9. All right, so kind of 3 parts to all of these variation equations, okay? Figure out which one it is based on what they tell you. Varies directly, varies inversely, varies jointly, okay? Fill in the numbers and find k. Then once you have k, use the second set of numbers they give you to solve for whatever it's asking for. All right, so I'll do 14 as well. Okay, so 14, if y varies inversely as x, so that means I'm using this equation. Y varies inversely as x. Y equals 23 when x equals 8. So 23 equals k over 8. All right, and if I'm solving for k, I'm going to multiply both sides by 8. Oh, no. Sorry. My camera setup is not very sturdy. All right. 23 times 8 is 184. So that's what k is. All right, then second part of number 14, find y when x equals 4. So my equation is y equals 184 over x. And they want me to find y when x equals 4. So I have y equals 184 over 4. All right, well, this one is an easy one. We just do that math. All right, 184 divided by 4 gives me 46. So y equals 46 would be your final answer there. Okay. All right, then let's go back to the first page of that. Those are the word problems, okay? And if you guys remember, I told you this, I think variation word problems are probably the easiest of the word problems because they lay it out directly for you. Okay, so I'm gonna kind of write this problem really quick. So don't judge my handwriting, all right? But time varies inversely as speed if distance is constant. All right, a trip takes 4 hours at 80 kilometers per hour. How long at 64 kilometers per hour? Okay, so time varies inversely as speed. There's your key sentence. Okay, time is going to be y, speed is going to be x, because in the regular, normal, not a word problem sentence, it would be y varies inversely as x. Okay, So that means my equation is going to be y equals k over x. All right. A trip takes 4 hours. All right. 4 hours is time. That's my y. All right. K, we don't know. At 80 kilometers per hour, that's speed. Okay. So if I solve this, I'm going to multiply both sides by 80. So K is 320. All right. Now that gives me enough information to use the 64. Okay, so 64 kilometers per hour, that's a speed, so that's going to be x. All right, so if y equals 320 over x, and I know that x is 64, okay, then I just got to do that math. And that would be 5, so it's going to take me 5 hours. All right, and that's really it as far as the different kinds of problems you're going to be asked to do. I will do as many examples as you want me to, but they're all going to be the same kind of problem. Okay, just different numbers. So, do you need more? I'll hang out here for about 10 minutes if you guys want to work on the remediation problems, and if you have a question, you can ask. But if you don't want any more examples, then we are good to go, and I'm just going to kind of sit and wait and see if you guys have any questions. You're welcome. Yeah, and if you're good, you're free to leave. Like, that's it. I'll stay here and do as many examples and answer as many questions as you want. But if you feel like you're good to go, feel free to leave. I will post the answers to that remediation so that you can check your work and then just make sure you have Delta Math done.